Hi, Assalamualaikum. My name is Hazeq bin Misuan. My student ID is 2019220634 and I'm from J4 EM110 4J. So today I'm going to present about lab 4 advanced for MEM460. For this lab, we have been given a product designs and we must complete the technical report by using the turning and milling process. So to produce this product, there are two parts, which are part 1 milling process and part 2 turning process. For part 1 milling process, I will explain number 5, which is the rough mill contour process. So number 5 is a rough mill contour process because contour milling can produce a continuous curve at different angles. Next, I will explain part B. Number 1 is cutting tool. I choose mu and mill cutting tool. This is because this tool is a suitable tool for machining any contour shapes in the workpiece during milling process. Number 2 is the description. The description that I choose for mu and mill is 20 as 20, 10, 150 to T. Number 3 is number of insert of fluids. The number of fluids is 2. Then number 4 is size DC dimension. The size that I choose is 20 mm. This is because, as we can see in the figure, the area for rough mill contour process is 180 mm times 84 mm. So the higher dimension, which is 180 mm, will be divided by 9 to get the size of cutting tool, which is 20 mm. Lastly, number 5 is LF and LH dimension. I choose LF as 150 mm and LH is 40 mm. Next, I will explain part C. First, we choose unit of measure is millimeter. The operation is milling. The material is steel low carbon and the cutter material is carbide, and it will give result. The cutting speed is 107 m per minute. For the rough mill contour process, the mill diameter is 20 mm because when we do the process, 180 mm will be divided by 9 to get the end mill diameter, which is 20 mm. Then we insert the cutting edge 2 and the machine max 6000. Then we click on the calculate and it will give result. The spindle speed 1700 rpm, chip load 0.12 mm per fluid, and feed rate 409 mm per minute. For the estimated time, the length of cut is 100 mm. This is because the area that will be cut is 180 mm times 84 mm, and we will take the maximum dimension, which is 180 mm. Then 180 mm, which is length of cut, will be divided by 409, which is feed rate. Finally, the estimated time is 0.44 minute. Next, for part 2 turning process, I will explain number 5, which is center drill process. So number 5 is center drill process because they are used to create holes at the center of a workpiece. Next, I will explain part B. Number 1 is the holder. I choose the tailstock chuck holder to hold the drill bit. Number 2 is the cutting tool. I choose the center bit drill HSS cutting tool. This is because this bit drill is designed for center drilling. Then for the application, there is no information about center drill process in the appendix. The same case goes for boring bar type and size cutting tool. Next, I will explain part C. First, we choose the unit of measure millimeter, and then the operation is drilling. The material is steel low carbon, and the cutting material is HSS, and it will give result. The cutting speed is 29 meter per minute. And then for the center drill process, the drill diameter is 20 mm because when we do the process, the hole diameter is 40 mm. So 40 mm will be divided by 2, which is 20 mm. Then we click on the calculate, and it will give result for the spindle speed 460 rpm, machine max 6000, cutting edge is 2, chip load is 0.396 mm per ref, and feed rate is 183 mm per minute. Then for the estimated time, the length of cut is 5 mm. This is because we want to drill a smaller hole by using center drill. Then 5 mm, which is length of cut, will be divided by 183, which is feed rate. Finally, the estimated time is 0.027 minute.